Good morning, this is Mr. Precella. Today we're going to discuss something called complex numbers. We discussed square roots the last time, and this is sort of continuing our discussion of square roots. Last time we talked about the perfect squares, and then we discussed how to simplify square roots that aren't perfect squares, like the square root of 50. You could think of it as 25 times 2. And you know the square root of 25, because 25 is a perfect square. So we can simplify square root of 50 to 5 square root of 2. And we went through simplifying more square roots like that. But there's one thing which we didn't mention. And since I'm about to start working, y'all don't need to be looking at the top of my head. So let me let this picture of me go. We're going to discuss something called complex numbers. And let's begin this by looking at a common mistake that students make. When a student sees something like this, the square root of negative 25, sometimes students will say, and this is wrong, I'm going to put a big red X through it right now. Negative 5. But that's wrong. The square root of negative 25 isn't negative 5. Why is that? Well, negative 5 times negative 5 isn't a negative 25. It's a positive square root, positive 25. If you think back to what we were doing with square roots, we never had a negative number underneath this square root symbol. Okay? So, how can we simplify square root of negative 25? In the past, you would say that that is not a real number. You've always heard your teachers talking about real numbers. And just by that tone, if there's real numbers, maybe you're thinking, are there some numbers that aren't real? And yes, they are. We're going to define the square root of a negative number to be an imaginary number. And we're going to use this lowercase letter I to denote imaginary. Let me show you what I mean. This square root of negative 25. I'll put the negative in green. Ooh, or does it look black? It's supposed to be green. Here's how we're actually going to simplify it. We're going to simplify the square root of 25 the way we normally would and just say 5. But then we're going to stick an I on it to indicate that there's a negative in front of the 25. We say the square root of negative 25 equals 5i. This is called an imaginary number. Let's look at our homework assignment over complex numbers. Now, on the left-hand side of the screen, that's where you'll see the media with little lectures and stuff. Yeah, you'll see my lectures. And let's see, this is a very famous textbook author and math teacher, Elaine Martin Gay, if you want to listen to her lecture over it. But you got to get the green checks before these questions light up. Notice I didn't really watch the video. I don't need to watch the video. Y'all will be watching the video. This video I'm making right now will appear there. Okay? So we will click on number 1. Let's see, what does that say? The square root of negative 64. Well, heck, that's sort of like the square root of negative 25. This first one's going to be pretty easy. What am I going to do? I'll say, okay, the square root of 64 is an 8. And then punch in a lowercase I. You'll notice down here there's an I. Or you can just use a lowercase I. When you're punching answers in with My Math Lab, do not hit space keys. Do not use capital letters. Okay? That's throughout the whole semester. No spaces, no capital letters. Okay? Notice how it spaced it right there. if you're doing it correctly, it'll space it correctly for you. Okay? Let's say check answer. Okay, and move on to the next one. Here it says square root, so this is problem number 2. Let me write it down. The square root of negative 108. Square root of negative 108. You know, I need to pull up my calculator. You can do it without a calculator, but I like having a calculator up for illustration purposes. So let me come back over here and let's see. I've got to open this up. Sorry, I should have done this beforehand. I thought I had. This is just a little free graphing calculator that I downloaded. There. Okay. Square root of negative 108. Well, 108 is not one of those perfect squares. Okay? 108 is not one of the perfect squares that we wrote. Okay? So how do we simplify that square root of 108? Well, let's see, which one of these, what's the biggest perfect square that divides into 108? Let me get that calculator. There. Okay, so 108, just sort of go through. I'm starting with the smallest one. 108 divided by 4. Okay, so 4 divides evenly into it. But what about the next perfect square? 9 does also. 16 doesn't, but there's a bigger one than 9 that does. 25 sure doesn't. What's the bigger one I'm thinking of? 36? What's 36 times 3? That's a 108. So, I'm going to rewrite this. Okay. First of all, because of this red minus sign, under the square root symbol, we're going to have a red I. I'll put it right there. And now let's break up 108 as 36 times 3. And now the square root of 36 is 6. The square root of 3 we can't simplify. And this I, it theoretically doesn't matter where you put it, but it's customary if it's between, if there's a square root symbol, you put it in front of the square root symbol. And you'll see that's going to be easier to type in. The I should not go under that square root symbol. If you did something like this, it's going to be wrong. You do this, 6 square root of 3i. Y'all tell the way the I looks like it's under the square root symbol. So we'll type in 6i square root of 3. I'm just going to hit the letter I. Square root, I could have used that I right there. Square root 3. Enter. Oh, now before we do that, I need to give y'all a definition. Throughout your previous algebra classes, you would have heard teachers talk about like terms and combining like terms. For instance, 3x plus 4y, 3x plus 4. You can't combine the 3 and the 4 because there's not an x on the 4. You can only combine like terms. Well, suppose we had one of these imaginary numbers and a real number. A real number is anything that's not an imaginary number. See, all of these over here, these are real numbers. Okay? So, if you have a real number and an imaginary number, combining them together. You can't really add the a and b. You just have to leave them like that, the same way you would leave 3x and 4. You can't combine that and get a 7. So a real number plus an imaginary number is called a complex number. Let me see. It seems sort of dark here, doesn't it? No. Okay. Let me turn on another light. It's just been such a dreary day. Okay. Well, let's see. Maybe that makes it a little brighter. Maybe it doesn't. So, a complex number is when you have a real number, that's a number that's not a square root of a negative, and one of these imaginary numbers. Okay? So, problems 3, 4, and 5 are all the same type of problem. Let's look at this one. Write the number in standard form. What the heck do I mean by standard form? Okay, simplify your answer. Type your answer in the form a plus bi. Use radicals as needed. So we're going to write this as a complex number. So let me write it down. Negative 3 negative 3 plus the square root of negative 27 all over 3. And when we're through with this, we'll have it written as a complex number. So let me see. Well, to begin this, you'll simplify the square root. Let's simplify that square root. Well, first of all, I'm in a room with some kitty cats. Sorry about that. There you go. Well, because there's a square root of a negative, because of this red negative sign I've written there, there's going to be a red I for imaginary. Now let's simplify square root of 27. Thinking, which perfect square divides evenly into 27? Well, that's not a hard one. 9. So we think of this as the square root of 9 times the square root of 3. And we can rewrite that by replacing the square root of 9. That green square root of 9 can be a green 3. We still have the square root of 3. Remember where you put the I? Right in front of it. So to get started, you simplify the square root. Now let me rewrite this. Negative 3 plus 3i square root of 3 all over 3. Now, most of you have a feeling that we can cancel something, and you're right. But you separate like this. When there's just one number on the bottom, you don't just cancel this 3 with one of these 3s. You're going to cancel it with both of them. Let me write this step out right here. You go negative 3 over 3 plus, this plus is that one right there, 3i square root of 3 all over 3. These little marks here are universal symbols for separate. Put both of those over 3. And now, let's see, negative 3 over 3, that reduces to negative 1 plus, cancel those 3's, and you have I square root of 3. So negative 1 plus I square root of 3. That's what we will punch in right now. Notice how you have an imaginary number and a real number. The negative 1 is the real number plus I square root of 3. Okay? Let's do another one. This one's number... Oh, that has some big numbers there, doesn't it? Okay, let me write it down. Problem 4 is 16 minus the square root of a negative 768 all over 4. Well, let's start off by simplifying. Let me move this up. Let's simplify under that square root. And let me go ahead and pull up a calculator. Okay, negative 768. Well, I'm simplifying the square root right now. Just do it right outside it. I'm doing exactly what I did here, but unfortunately the number's a little bit bigger. Let me go ahead and make a note that because of this red negative, there's going to be an I. So I'll put that there. And let's just start with my calculator, figuring out which of these perfect squares divides evenly into 768. Okay. Turn this on. Oh, let me clear that. Let's see. 768 divided by 4. Does 4 divide into it? Yeah. Is there anything bigger? 9 does not. Let's see. 16. Okay, let's see. 25 doesn't. 36, probably, no, because 9 doesn't divide into it. What about 64? 768 divided by 64. What's that? Oh, 12. 768 divided by, I'm just looking at these perfect squares. Does 144 divide evenly into 768? No. 768 divided by 64. Oh, it's going to be a much bigger number. Let me show you how you can break this thing up. Okay, you can think of the 768 as 64 times 12. Then break this up into 2 steps. So the square root of 64 is an 8. But that square root of 12, we can break that up further by calling 12 4 times 3. So if I think of that 12 now as 4 times 3. The square root of 4 is a 2, so we have 8 times 2, which is 16, square root of 3, put the I right here. Okay, so let's see, let me clear this. What's 16 times 16? See, it's 256. So 256 is the perfect square that divides evenly into, yeah. Okay, so if we'd done it all as 256 times 3, that would have gotten us there faster. But I wanted to show you how if you can't figure out what's the absolute biggest, just break it up in steps. 64 times 12, square root of 64 is 8. Then simplify square root of 12 is 4 times 3. Okay? So, we now have, I'm rewriting the problem, 16 minus 16i square root of 3 all over 4 Now don't just cancel this 4 with one of these 16s. Cancel it with both. And let's see what we have. 16 over 4. That would just be a 4. This minus is that minus. Another 16 over 4 is just 4i square root of 3. So 4 minus 4i square root of 3. Hopefully when you do it, your number won't be quite as big under the square root symbol as mine. Y'all remember what I said you call the number under the square root symbol? It's called a radicand. So 4 minus 4i square root of 3. Just flying right on along. Number 5. Oh, good. Number 5 has some smaller numbers here. We'll write it down. Negative 12 plus the square root of negative 16 all over 60. And I said negative 16, and I just see that that's not a 16. That is an 18, isn't it? Okay, that's an 18, not a 16. It's a good thing I spotted that. Negative 12 plus the square root of negative 18 all over 60. Okay, we'll simplify the square root of negative 18. Always stick the I out first, okay, so I don't forget it. Square root of a negative is an imaginary. And here, what perfect square divides evenly into 18, 4, 9, 16, 25? Well, that's not too difficult. 9. 9 times 2 would give us 18. And what green number do I have now? Well, the square root of 9 is a 3. Then I put the I and the square root of 2. So rewriting this, let's see, we have negative 12 plus 3i square root of 2 all over 60. And this is where normally I draw the little marks and separate. But on this one, am I going to still wind up with a fraction? When I separate here, yeah, I'm going to wind up 12 over 60. I could reduce to 1 over 5, but there's still going to be a fraction. So if that's how it's going to work out, here's how I like to simplify it then. It'll be easier to type in the answer if you write it this way. Look at the 3 numbers that aren't under the square root and ask yourself, what number divides evenly into all 3 of these numbers? 3, 12, and 60? Well, the only number that divides evenly into all of those is a 3. So I'm going to divide every one of these numbers by 3. Negative 12 divided by 3 is negative 4. This is that plus. 3 over 3 would just be 1. So I square root of 2. 60 over 3 is 20. Okay. That's one way you could write your answer. Now, if you actually wanted to do this and break it up, your answer is going to look a little different. The negative 12 over 60 would reduce to negative 1 over 5. The 3 over 60, let's see, 3 goes into 60, is that 20 times? Pearson will take both of these answers. I think this one is the easier one to write. The one with just one big fraction, or to type in. Okay? Here's 2 different ways you could write the same answer. Okay? So, but I'm going to type this one in. Oh, it's another one of my kitty cats is sticking his head in here. Okay? So to type this in, I'll click in here so I get the tools, and I'll click the fraction bar. And up on top I write -4 plus I square root of 2. I'll click on the bottom and put a 20. Okay. Let me check. Uh-oh, what did I do wrong? Oh, check to make sure it is not in the correct form, although your answer is equal to the correct answer. Oh, they don't want me to put it in this form, okay? We'll be writing it like this later on in another homework assignment, but what they want me to do is to punch it in. Oh gosh, okay, I don't like this. Okay, well, that's a good illustration. Let's see. Gives you an example of what happens. Okay, well, I'm going to have to punch it in this way. It used to let me punch in both forms, here or here. Well, I'll see maybe in the next homework assignment, will they let me do it either way. But they want it punched in like this right now. So, okay. That's something different. So I'm punching in that other one, the -1/5. I'll go negative. For just a simple fraction, 1/5 would be fine. But you need to hit the right arrow or else move your mouse and get it out. Don't put the plus down there in the bottom of the fraction, you see? So I'll go right arrow, plus, oh, the next is a messy fraction, so I'm going to use that. I square root of 2 all over 20. Okay, and I'll say, check the answer. Okay. So that was interesting. Later on in the next assignment, it'll be taken either form. These are two ways of writing the same answer, but they wanted, I guess, clearly A plus BI, the imaginary part there. So, okay. Now we mentioned combining like terms. What we're about to do is start adding and subtracting complex numbers. To add or subtract complex numbers, you combine the like terms. So let me write this one down. It is -2 plus 9i plus 9 plus 9i. The parentheses are here in order to separate. Here's one complex number. You're adding it to another complex number. You'll combine this the same way you did in a previous algebra class when you were just adding polynomials. You combine like terms. You can't add a number that has a variable to a number that doesn't have a variable on it. Okay? So combining the like terms, I can combine the -2 and this 9 here. -2 plus 9, that's a 7. And then I'll add the I part. 9i plus 9i, 18i. So you just add the real numbers together, add the imaginary numbers together. So what did I get? A 7 plus 18i. Number 7 says, okay, what do we, oh, come on, kitty cat, get down from here. I don't know why the all over the place today. Normally they just leave me alone when I'm doing this. Number 7, let me write it down. Kingfish. Oh, we hit. Go, go, go. 3 minus 6i minus 4 plus 2i. No. Oh, talking to the cat. I'm sorry about this. We're making this video here when everyone is working at home during the pandemic. Okay, so I have 3 minus 6i minus 4 plus 2i minus a negative 4 plus I. Here we are subtracting complex numbers. And when there's just plus in front of the parentheses, there's really nothing to do. Just add the terms. They're like terms. When there's minuses in front of the parentheses, you've got to distribute the minus. Remember in a previous math class? Distributing a minus? Or maybe you multiplied by negative 1, if that's what you want to call it. But if there's a minus in front of the parentheses, you change the sign of the numbers in the parentheses. So I'm going to write it without any parentheses. 3 minus 6i, then a minus 4, and a minus 2i. Now minus and negative is a plus 4, plus 4. And then what is that, a minus I? Now let's combine all our like terms, keeping in mind that when you have a variable and there's not a number in front, you assume there's a 1 there. So let me see. I'm adding the real numbers. 3 plus a negative 4 plus 4. Okay? Is that just going to be 3? Minus 4 plus 4 is 0, so 3. Now let's do the imaginary parts. Add up. Negative 6 plus a negative 2 plus a negative 1. Is that a negative 9i? So 3 minus 9i. So what's tricky here is if there's a minus in front of the parentheses, be sure to distribute that minus sign. So let me pull it up and punch this in. 3 minus 9i. Okay? So adding and subtracting complex numbers isn't that difficult. We're now going to start multiplying complex numbers. But before we do, I want to make an observation. So we were discussing square roots. Remember we said something like a square root times itself. You could just say equals whatever's under the square root. Like the square root of 31 times the square root of 31 is just 31. Square root, I think it was a red star rule. The square root of a times the square root of a is just a. Or another way of writing it is the square root of a squared equals a. Let's make an observation. I'm deriving a rule. How would you simplify this? The square root of negative 1. If you were simplifying that, you would do, like here, this square root of negative 25, you said 5i. Okay. Just a 1 under there, the square root of negative 1 would just be a 1i. Now, let's square both sides of this. Why? Because I'm going to develop a little rule that I'm going to put a star by in a moment. If I squared both sides, I can use that red star rule from the last time, where a square root and a square cancel each other out. So that square root and square cancel each other out. Now let me go ahead, I would have then just a negative 1 equals I squared, because the square root and square cancel. Now let me go ahead and reverse the order here. Let me write it like this. I squared equals negative 1. I'm going to circle this and call it an important rule when working with complex numbers. Okay? I squared is equal to negative 1. So why am I writing that, and what are we going to be using that for? Well, whenever you have an I squared, replace it with negative 1. If you look through everything we've done so far, there's never been a square on any of our i's. That's why we haven't done it yet. We've added complex numbers, subtracted. The next problem, number 8, we're going to start multiplying complex numbers. Look at number 8. Move this up and write out the problem. It says 6 plus 8i times 2 minus 9i. 6 plus 8i times 2 minus 9i. Notice, how does this problem differ from the ones we were doing? Well, the ones we were doing, see, there was a plus or a minus in the middle of the parentheses. If there's not a symbol in the parentheses, then we consider it that multiplication. So how do we multiply this? Well, y'all remember something called FOIL? First, outer, inner, last. That's what we're going to do here. To multiply complex numbers, you FOIL them out. So first, 6 times 2, 12. Outer, let's see, 6 times a negative 9i. Is that a negative 54i? Inner, what's that inner there? 8i times 2 is a 16i. And last, 8i times a negative 9i, is that a negative 72? Now be careful, it's not just I, it is I squared, I times I. When you FOILed stuff out in a previous algebra class, your variable was probably not an I. The variable you were using was probably an X. And you'd say X times X is X squared. Well, don't let the fact that this is I scare you. Before you combine the like terms now, you're going to have to do something. Every time you see an I squared, you should replace it with a negative 1. So what's that going to do to this negative 72? When you multiply a negative number times a negative 1, is that just going to change this from a minus 72 to a plus? Y'all see what I just did? You replace the I squared with negative 1. So negative 72 times negative 1. Negative times negative is always a positive. And then I'll carry this down. And now I'm ready to combine the like terms. What can I combine with the 12? Well, 12 plus 72, is that a 84? And negative 54 plus 16, that's going to be a negative what? Is that a 38? So I added the real numbers together, and then I combined the imaginary numbers together. So 84 minus 38i. So to multiply complex numbers, you just FOIL or multiply binomials. That's what you would have called it in a previous algebra class. The new stuff is when you get the I squared, you need to replace it with the negative 1. which is going to do what? Just change the sign in front of that number. So 84 minus 38i. 84 minus 38i. 84 minus 38i. Okay. Let's do another one of these. So number 9. Oh, okay. Number 9 looks sort of different from the other one, but it's actually exactly the same type of problem with one additional step. Negative 8 plus 9i all squared. Well, this is going to illustrate that basic problem-solving technique, strategy. When you know how to do one type of problem, you know how to FOIL it out and replace I squared with negative 1. That's what we just did there. And we're confronted with the new one. Well, let's try to make this problem look like this one. What do I mean? This one has two sets of parentheses. Doesn't square mean times itself? So just write out 2 and then FOIL it out, replace the I squared with negative 1. Exactly the same type of problem. Okay? So FOIL means times itself. Let's see. First, outer, inner, last. So let's get started. That would be a 64. Negative 8 times negative 8. The negative 8 times a positive 9 is a negative 72i. Then another negative 72i. 9i times 9i is a positive 81i squared. Replace the I squared with negative 1, which is just going to change this plus here to a minus. Okay. To speed things along, I won't bother rewriting it. All I've done is change this plus 81i squared. All of that's gone. It's just a minus 81 now. So we have 64 minus 81. That's going to be a negative number. Is it a negative 17? And then combine the two I terms. Negative 72 plus a negative 72 is a negative 144i. So negative 17 minus 144i. Negative 17 minus 144i. Okay, number 10. Let's see. Number 10. Okay, I had to take a little break there. One of my cats is having allergies and it's just up here on the table sneezing away. Let me tell you, it's a heck of a lot easier to make these videos at school than at home. But let's see. Here, negative 3i times negative 8 plus 6i. Well, here we don't really need to FOIL. All you got to do is just distribute the negative 3i. Negative 3i times negative 8 is a positive 24i. The negative 3 times a positive 6 would be a negative 18i squared. Now, whenever you have an I squared, you need to replace it with a negative 1. So if I replace this I squared with a negative 1, all that's going to do, negative 18 times negative 1 is just going to be a positive 18. So I'm just changing the sign on the 18 and marking that I squared out. So we have 24I plus 18, or 18 plus 24I. That's how we would write it if we wanted it in that standard form, A plus BI. Now, Pearson used to let you punch it in either way, and I'm just curious. If I punched it in 24I plus 18, would it take it? Or does it have to be the 18 plus 24I? 24I plus 18. No, they want, your answer's equal. They want it in that form, 18 plus 24I. Okay, that's something new. 18 plus 24I. Okay. Okay, number 11. Looks like it's another FOIL problem, isn't it? Negative 5 plus 9I times 6 minus 2I. Let's start foiling it out. We have a negative 30 plus 10I, negative 5 times a negative 2I. 9I times 6 would be a 54I. And 9I times a negative 2 is a negative 18. And I times I is a I squared. Before we combine, we need to replace the I squared with a negative. Oh my goodness. I forgot to show y'all my work. Let me see. Still showing this screen. So I foiled it out. Negative 30I plus 10I. No, negative 30. Negative 5 times 6, negative 30. Negative 5 times a negative 2 is a positive 10I. 9I times 6, 54I. 9I times a negative 2I, negative 18I. I squared, Replace the I squared with negative 1. So if I replace this with negative 1, negative 18 times a negative 1 is just going to be a positive 18. So I'll just mark out the I squared and change the minus to a plus in front of 18. So let's see. Negative 30 plus 18 is negative 12. 10I plus 54I is a positive 64I. So negative 12 plus 64I. Negative 12 plus 64I, and problem 12. Let's see, what is that? 5 plus 3I times 5 minus 3I. Well, let's see, we have a 25, then a minus 15I, that's, I'm doing it again. Let me start foiling it out. 5 times 5, 25. 5 times a negative 3I is a negative 15I. 3I times 15, would that be a plus 15I? And then 3I times a negative 3I, is that a negative 9I squared? Oh, this one's going to simplify real nicely. You see the 15i's, negative 15i plus 15i, those subtract out, don't they? 15 minus 15. Now, what do we do with the I square? We say the I square is negative 1. Negative 9 times negative 1 would just be a positive 9. So we'll change that to a plus 9. So we have 25 plus 9. That's just a 34. No imaginary number here. This answer is just a real number. 34. Okay. Now, the next, we've added, subtracted, multiplied. What do y'all think's the next thing we're going to do? We're going to divide complex numbers. Not a lot of applications of complex numbers at the elementary level, but eventually any future electrical engineers, you're going to see a lot of stuff with complex numbers. If you're an accountant, no, you wouldn't use complex numbers. Dollars and cents, those are all real numbers. But for electromagnetic field theory, a lot of this complex number stuff. All we're doing is just adding, subtracting, multiplying, dividing complex numbers. When we talk about division of complex numbers, we don't mean long division. It's written as a fraction. 8 plus 4i divided by 1 plus I. That's what we mean by divide. But before we do that, I need to give you a little terminology. So here's some terminology. If you have two complex numbers, a plus bi and a minus bi, by that I mean they differ only by the middle term, middle sign. Okay? The same numbers, but different signs. Those are called conjugates or complex conjugates. A plus bi and a minus bi are called conjugates. Something interesting about multiplying conjugates, like right here, 5 plus 3i and 5 minus 3i. These are conjugates, and notice when you multiply them out, these middle terms are always going to subtract out. So we can make the statement that if you multiply two complex conjugates together, you're going to get a real number. Okay? If you multiply a plus b times a minus b, those middle terms are always going to subtract out. Okay? X plus y times x minus y. Those are conjugates, and you just get x squared minus y squared. To divide complex numbers, multiply above and below, and the problem is going to look like fractions, above and below, by the conjugate of the denominator. The denominator is the bottom part of the fraction. D for down, if you've got to remember it. Okay. And let me show you. We're going to do problem 13, and this will illustrate what I'm trying to say. We'll write down problem 13. Eight plus 4i divided by 1 plus I. This is division of complex numbers. Well, in order to divide these, we're going to multiply above and below by the conjugate of the denominator. So here's the denominator. What's the conjugate? Well, to find the conjugate, you just change that middle sign. I'm going to multiply above and below by 1 minus I. We're going to have to FOIL out twice here. You multiply above and below by the conjugate of the denominator. The conjugate of the denominator, you just change the middle sign. Don't change anything else. So 1 minus I. So you're going to FOIL the top and FOIL the bottom. Foiling the top, we'd have 1 times 8. 8. Then a minus 8I. And is this going to be the inner one? Would that be a plus 4I? And then the last, watch out, here's where you get an I square. 4I times a negative I. Is that going to be a negative 4I squared? Now, foiling the bottom. 1 times 1 is 1. Then a minus 1I, I'll just say minus I. I times 1 would just be a 1I or I. And then I times a negative I would be a negative I squared. Now we got to combine the like terms. But remember, before you do that, you need to replace these I squares with a negative 1. Negative 4 times negative 1, that's just going to be a positive 4. What about here? Well, there's not a number there, so we'll assume there's a 1. Replacing the I squared with a negative 1. Negative 1 times negative 1. That's a positive 1. So all of this I squared stuff is gone. All that I squared does is change the sign of the number in front of it. So now let's combine the like terms. 8 plus 4 is 12. Negative 8 plus 4I is a negative 4I. So I added 8 plus 4, the real numbers, and then I combine the imaginary. What's happening on the bottom? Well, whenever you multiply conjugates, those middle terms always subtract out. All we're left with is 1 plus 1, so is that a 2? On the bottom. Now, when it's just a number on the bottom, you separate it. That's what we did on problems 3, 4, 5, where you separate 12 divided by 2. Would that be a 6? And what's 4 over 2? Is that just going to be another 2i? So 6 minus 2i. So this is something that you really couldn't just look at it and guess. 8 plus 4i divided by 1 plus I is 6 minus 2i. 6 minus 2i. Number 14. Here's another one. Let me write it down. 8 plus I times negative 5 minus 2i. Eight plus I divided by negative 5 minus 2i. Okay. Well, to divide complex numbers, multiply above and below by the conjugate of the denominator. Now this one's tricky. What's the conjugate of the denominator? With conjugate, you only change the middle sign. Sometimes students want to change the sign on the 5 too. No, no, no. Only the middle. Negative 5 plus 2i. Negative 5 plus 2i. You multiply it above and below by the conjugate of the denominator. And with conjugates, you just change the middle sign. Let's see. Let's start foiling it out. 8 times negative 5 is negative 40. 8 times 2i, 69. I times negative 5, negative 5i. I times 2i, 2i squared. Now foiling out the bottom, that's where it's going to be conjugate, so you can expect the outer and inner to subtract out. Negative 5 times negative 5, it's a 25. Then a minus 10i and a plus 10i. And then negative 2 times I times a positive 2i, that's going to be a negative 4i squared. So replace those I squares with negative 1, which is just going to change the sign in front of this 2. So instead of a plus 2, we're going to have a minus 2. It's a little messy, isn't it? Down here, replace the I squared with the negative 1. Negative 4 times negative 1, that's just going to be a plus 4. Okay. So let me draw my fraction bar and let's see what we're going to have. Negative 40 minus 2, is that going to be a negative 42? 16 minus 5, is that going to be a plus 11i? And what about on the bottom? The I subtract out. 25 plus 4 is 29. Now, on this one, if we do this and break it up, is anything going to cancel? Negative 42 over 29 plus 11i over 29. Nothing cancels, right? When nothing cancels like that, if you break it up, in the past, Pearson has let you just enter the one fraction. This one right here. Okay? I'm going to try and see if I enter that one, will they take it, or do they want it like this? Okay? So, since nothing will cancel at all, in the past they let us enter it like that. But they might want us to write it like this. And you get 3 chances, that's why, okay, let me just see, will it take this? Okay, there's a fraction bar. And I'm just going to punch in the big fraction, the negative 42, oops, negative 42 plus 11i all over 29. Will it take that, or is it going to make me, nope, okay. So that's one change. It used to be, they didn't make you break it up like this. So negative 42 over 29, right arrow, plus 11i over, I'm just hitting the slash, 29, enter. Okay? So I've learned something new. What did I learn? They used to let you punch it in like this, but during this pandemic. They've done some updates, and now we have to break it up like that. Okay. So one more. This is problem 15, the last one, so it has to be the hardest, right? Isn't the last problem usually the hardest? Let me write it down. Number 15. 7. So we're dividing a real number, 7, divided by 3 minus 7i, the complex number. Well, don't let the fact that there's no I on top scare you. Still, just go about it the same way. Multiply above and below by the conjugate of the denominator. The conjugate of 3 minus 7i is 3 plus 7i. So let's see. Well, up on top, that's not bad. It's 21 plus 49i. 21 plus 49i. On the bottom, this is where we're multiplying conjugates, so you can expect the outer and inner terms to subtract out. We'd have a 9, and then a plus 21i. First outer. Inner is a minus 21i. Last, is that a minus 49i squared? So there's only one I squared on this one. Nothing we can combine up on top. But on the bottom, there's a lot. The 21i subtract out. If I replaced this I squared with a negative 1, negative 49 times negative 1, that would just be a positive 49. Hopefully y'all got the hang of wherever there's an I square, just change the sign of the number in front of it. Now I'll mark out that. So on top, we have 21 plus 49i. And what do we have on the bottom? A 9 plus 49? Is that going to be a 58? And it used to be we could just type that in, because when you separate it, I don't think anything's going to... 21 over 58 plus 49i over 58. Nothing cancels, but as we've seen, they're going to want us to enter the second one, okay, the two separate fractions. 21 slash 58. Don't put the plus down there. I'll just move right arrow and then put the plus 49i slash 58, or you could have used the fraction bar or fraction key if you want. So now I will check it, and if you look right up here, oh, notice my grade is going to change from a 98 to a 100. Okay? So, what have we done today? Well, we continued our discussion of square roots by defining what we mean by the square root of a negative number. The square root of a negative number is an imaginary number. And let's see. And then we went through saying, okay, if you have a real number that doesn't have an I with an imaginary number, you can't combine them together. We'll just call them complex numbers. Okay? And then we went through simplifying some complex numbers, and then adding, subtracting, multiplying, dividing complex numbers. Okay? Not a lot of applications at an elementary level here. All we're seeing for complex numbers is just the arithmetic of complex numbers. We'll leave applications to your future engineers, to your physics class and engineering classes. Here, all you're learning is just how to simplify them and what they are. Okay? Well, this has been a pleasant class session, and I'm going to go ahead and say goodbye now. Hopefully you're working on your homework. Oh yeah, I just finished that. I'll say save it. And let me go ahead and pull up there. Okay. Now don't forget, you have to check on your, watch the little videos here. For your assignment, you'll probably have fewer videos. In fact, one of these videos right here will be the video I just finished making. Okay? Let's see, it's a Saturday right now, so I hope you're having a good weekend. Stay safe. This is the middle of we're still in the pandemic, although vaccines have come out, so hopefully soon we'll be vaccinated and life will return to normal. But have a good weekend, and goodbye. Peace. Bye-bye.